All right, so Unit 2 differentiation. Again, wrap your mind around this. This is the main focus of the entire unit, the slope of a point. All you care about is the slope of a point, instantaneous rate of change, slope of a tangent line. There's so many names that you can have for derivative, but this is what a derivative is, the slope of a point. Okay? I've had students that can do all the formulas, all the derivative rules in their sleep, and then they don't even know what a derivative is. Okay, it's probably happened in a lot of your math classes where you're just kind of working out an algorithm but not understanding what you're really doing. People they don't understand what they're doing. They can just do it, but they don't understand why, like the concepts behind it. So make sure you understand that slope of a point, derivative. Okay, right now you should be able to answer questions 1, 2, 3, 4, 5, 6, and 7. So yeah, we only have one more left, which is 8. Okay, so I'm going to go through this really quick. How is the slope of a tangent line calculated? Thoughts on that's very open-ended. There's not like one answer to it. The slope of a tangent line is the derivatives. How is it calculated? Generally speaking, it's calculated using derivative rules, but the idea behind those rules is limits. Okay, and hopefully you watched those videos. You saw where all of those rules came from, and they all stemmed from that. The limit is h approaches 0 of f of x plus h minus f of x all over h. Okay. It's based on that one principle. You're finding when 2 points get infinitesimally closer together, that's the slope of a tangent line. How is differentiability defined? It has to be continuous at that point, okay, and the derivative has to agree on both sides of that point. Okay, that's how that's defined. How can a derivative be estimated at a point? Finding the slope of points that are around it. It's so lame because it just never would happen in real life, but that's how it would be estimated. 4, how are derivatives found using differentiation rules? That's basically all those videos that you watched before, but there's power rule, constant multiple rule, product rule, quotient rule, chain rule. There's all those rules, exponential rules, log rules for derivatives. But it's basically just, using those formulas essentially. How are derivatives found? I just kind of went over that. I went over 6. I guess 6 would be using those formulas. I mean, that's how would you find product rule and quotient rule using those formulas for it? How are derivatives found using chain rule? Again, using a formula, and then derivatives found with implicit differentiation. That's the hardest thing of the unit. We're going to go over that tomorrow. Okay, so we did a super quick day with 2.1. Right, we just did one day with it. We're going to do a lot more practice next week, leading to the test. 2.2 is what we're starting today. 2.3 is tomorrow. Derivatives, secant lines, tangent lines. Make sure you know the difference between those two things. You should know this already from Algebra 1. It's the definition of slope. Limit definition is still based on slope, but the points are getting infinitesimally closer together. So the way I like to look at it is this h is just a little nudge. Super close to f of x. It's just a little bit over. Okay, but it's getting infinitesimally closer, but never reaching it, because then you would have 0 over 0. You can't have 0 over 0. Okay, make sure you understand f prime, y prime, dy over dx. That all means the same thing, derivative. Okay. Alternate definition. I am going to give you one of these problems today so you can kind of see how it works. These are very helpful. Well, it's not very helpful. It's generally used for finding the derivative at a point. I don't like it compared to this one, but everyone's different. Second derivative, you can have y prime prime, or I say y double prime, or f double prime, but you can also have this d squared y over dx squared. And the main reason I'm showing you that is because sometimes one of your questions will be like, find d squared y over dx squared. In your brain, translate that to English. It means second derivative. Okay? It's a very bad notation, but no one seems to be bothered by it except for me, apparently. Okay, make sure you know how to find the derivative on your calculator. We went over this yesterday. There's also videos that show how to do that as well on the website. Differentiability, make sure it's continuous. Make sure the derivative agrees on both sides. We already talked about that. Estimating a derivative at a point. If you can't find the derivative at a point, use points around it. Estimate it. Make sure you use the little squiggly equal sign, the approximation equal sign when you're doing that on tests. So we're going to say that later on because AP expects you to do that. Derivative rules. The main thing for the algebraic one is power rule. Okay, bring the power down. So it says C, but then it goes to Cn on the right side. And then you do n minus 1. So you're losing one of the powers there with the n minus 1. Transcendental functions, we don't teach it this way at the school for some reason, which I don't understand why. But algebraic means like polynomials, rationals, things that are just you could solve algebraically. Transcendental are equations you cannot solve with algebra. Unless you when you take Calc 2, you'll figure out how transcendental relates to algebraic, and it's insane. And the main principle behind it is going to infinity. It's crazy. Like e to the x can be viewed as a polynomial, which is, think about that first. That's pi can be viewed as, it doesn't matter. Sorry, I'm just getting on it. So all of these trig, exponentials, logs, those are called transcendental because they transcend algebra, which really they don't. Again, you'll learn that in Calc 2, but inverse trig, make sure you know those. Yeah, just start memorizing these. Certain trends you'll notice on these is anything with a like cosine, cosecant, arc cosine. Oh, by the way, those arcs, they're really inverse sine, inverse cosine, inverse tan. I just don't like the notation of like tan to the -1 because it's really not tan to the -1 power. They just put a -1 up there. Super annoying. Also, AP does arc. They actually, I think they started doing both, but like AP does have arcs in there. That just means inverse trig. If you remember, it was like sine to the -1 power. That's what the arc means. What else did I want to talk about? Oh yeah, cotangent. If you notice, all the cos derivatives are negative. Okay. So that's one way of looking at it. There's some certain symmetry too. If you look at the derivative of tangent right here, it's secant squared. So the derivative of cotangent is negative cosecant squared. So it's kind of like secant, cosecant, positive, negative kind of a thing. One thing that throws people off is sine that goes to cosine. They think cosine goes to sine. Doesn't. It's negative again with the cos. These are really annoying to memorize as well. Kids forget those a lot. But hopefully throughout the course, these will start, being etched into your brain. All right, product rule, quotient rule. Quotient rule is way harder to memorize. A lot of students forget that one. The way I always view it is, for whatever reason, my memory always remembers the g squared, just because it's weird. I don't know, there's a g squared on the bottom randomly. Product rule is pretty easy because it's just they switch like dancing partners. One's a prime, the other one's not. This one's prime, the other one's not. The order doesn't matter for this one. Now, order does matter for quotient rule. So the way my memory works is I just think all I need to do is remember the first one. If you just remember GF prime, the other one's the opposite. Okay? Now, if product rule, you remember that it's plus, this one's just the opposite with the minus, and then the weird thing is the g squared. So really the only thing you really need to, the thing that students mess up the most is the GF prime or the FG prime, the order of that. So I always just start with GF prime, okay? That's what is in my brain. I always just think GF, that's like girlfriend prime. If you have a girlfriend, she should be the prime thing in your life. Now I just always etched in my brain. The stupider the reason it is to memorize something, the more likely you are to remember it. Okay, you've probably done that with like learning languages. Like I can't think of, like if you're learning Spanish, like doesn't hablar mean to speak? And like I always think, oh, you're babbling, and that's kind of part of the word. Or like, isn't coachar to drive or something like that? Coche is car. Like coach, there's an AR at the end and a C in the beginning. Okay. Silly things like that, they're called mnemonic devices. You've probably learned them in Spanish or other languages that you've taken. The stupider it is, sometimes the easier it is to remember it. If you're really into like learning about stuff with memory, I highly advise looking up, like it's called a memory palace. Does anybody know what that is? Okay, it doesn't matter, but it's really interesting. Anyway, here's just another way it's rewritten. It's just the of x, so f of x, g of x. I just like it written like this because there's no x in there. It makes the formulas a little bit easier to use. Chain rule, what you do here is, actually I don't even like using this formula. I'm going to kind of show you my way of doing it. I call it onion rule because you're basically peeling back layers of an onion to do these types of problems. And you always go with the outside layer first because if you were peeling back layers of an onion, you would be starting with the outside first. So it kind of matches that. To me, a chain is not a function inside of a function. So I don't know why it's called chain rule. I think because it chains along on the right. But if you really think about it, a function inside of a function, chains aren't inside of themselves. We're like onions, or you think of those, you know, those dolls where there's a little one inside of it and then it keeps getting smaller. I think they're like, yeah, but that's kind of how I think of it as. This is huge because we teach inverse functions so terrible. In my opinion, we don't focus on it a lot in this school. So that's the derivative of an inverse function, but I'll go over that in a little bit. Again, that's going to be going over tomorrow.